Hello everyone, welcome to Math 2, Unit 6. This is lesson 6.3 and we are on activity 2, building an equation for a circle. The image shows a circle with center -3, 6 and radius 13 units. Question 1. Write an equation that would allow you to test whether a particular point xy is on the circle. In the previous activities, you were asked to test whether specific coordinate pairs were on the circle, and now we have variables that could represent any number. So we're starting to begin the process of generalizing how to test whether a point is on the circle. Let's start by drawing out a right triangle. And using the hypotenuse to represent the distance between the center and the point x, y. Remember that this is also the radius of our circle, and we're given that the radius is 13 units. So let's go ahead and label that here as 13. And let's look back at the previous activity and review how we found our distances, right? These were our side lengths of our right triangle. We use the coordinates of a particular point and the center to find the lengths of the right triangle. So if you look back over here, right, from our previous example, we had subtracted the difference between the y coordinates for our a value here. So here that would have been 25 and 10, right? So this whole distance was 25 minus 10. Okay, and then when we were trying to find our horizontal distance, right, we subtracted our x coordinates, so our 14 minus 6, and then that gave us our 8. So we can still apply this process when our point is xy. We will just have to use x and y instead of actual numbers. So I'd like you to pause the video and try solving number 1 by yourself, right? You have the previous activity. Number 1 is just an extension right now and our first step in generalizing this. So let's look at number 1. In our previous example, we had subtracted 10 from 25, right? So here, for our y value, which we don't know, right? We don't know this y value. We can subtract 6, our center point, right? Our y coordinate of our center point from our y value. So y minus 6. This will give us this vertical distance over here. For the horizontal distance, right, we can subtract the -3 from the x value. So I'm going to use green for that over here. We have x minus -3, right? Don't forget that we are subtracting this -3 here, so we've got both of those negatives in there. So remember that we can use the Pythagorean theorem. A squared, I'm going to write this up here again for reference, a squared plus b squared equals c squared. We can use the Pythagorean theorem to find the distance between the center point and a particular point on the circle. That's kind of how we were going about trying to find whether a particular point was on the circle. So here we can actually say that this is our A. This horizontal distance is our B, and then we know that this 13, this was actually our C. Right, so if I write this down over here as A squared plus B squared equals C squared, let me put the plus in here. We know that A can be represented by y minus 6. So I'm actually going to replace the the A with the y minus 6. So we can write y minus 6, the whole thing squared, plus we know that our B value here can be represented by x minus a -3. So I'm going to write x minus a -3. And remember, it's the whole thing squared equals our c squared. And in this case, we actually know that our c is 13. So I'm going to put 13 squared. So let's simplify this a little bit more. we've got y minus 6 squared plus, and remember, when we are subtracting a negative, right, when we've got this negative and negative here, it becomes an addition situation. So when we're subtracting a negative, we can actually just write this as x plus 3, the whole thing squared, equals 13. So we have now written an equation, I'm going to box this over here, which allows us to test whether any point xy lies on this circle, right, where we've got our center of negative 3, 6, and a radius of 13. So now we're going to apply this equation in question 2, and I will see you in the next video.